From the air we breathe to the objects we touch, our everyday world is a fascinating tapestry woven from countless chemical interactions constantly unfolding. Yet beneath this visible reality lies an unseen universe of tiny particles and forces. Imagine delving deeper, far beyond what our eyes can perceive. At the very heart of every atom lies a dense, energetic core called the nucleus. It acts as the central powerhouse, determining the atom's fundamental nature. Protons are positive, neutrons neutral, and electrons negative. These three subatomic particles residing in or orbiting the nucleus are the fundamental building blocks of everything. The number of protons in an atom's nucleus uniquely determines its identity, classifying it as a specific element like hydrogen, oxygen, or gold. While an element's identity is fixed by protons, atoms of the same element can have varying numbers of neutrons, creating fascinating variations called isotopes with unique properties. Atoms can achieve stability by gaining or losing electrons, transforming into charged particles called ions, which play crucial roles in countless chemical reactions. In covalent bonding, atoms achieve stability by sharing electrons, forming strong connections that create molecules like water, linked by a common bond. Ionic bonding involves the complete transfer of electrons between atoms, creating oppositely charged ions strongly attracted to each other, forming crystalline structures like salt. From water to carbon dioxide, simple molecules are formed when a few atoms bond together, creating the fundamental units of many substances we encounter daily. In a solid, particles are tightly packed and vibrate in fixed positions, giving substances a definite shape and volume. Think of a stable crystal holding its form. In liquids, particles are close but free to move past each other, allowing them to flow and take the shape of their container while maintaining a constant volume. In a gas, particles are widely spaced and move rapidly and randomly, completely filling their container. This freedom gives gases no definite shape or volume. Chemical transformations involve atoms rearranging, breaking old bonds, and forming new ones. This fundamental process creates entirely new substances with different properties. Every chemical reaction involves energy. Some release heat, like burning wood, while others absorb it, driving the creation of new molecules essential for life. Catalysts are nature's accelerators, speeding up chemical reactions without being consumed themselves. They are vital for everything from industrial processes to biological functions. Acids and bases represent two fundamental chemical properties, characterized by their pH. They are everywhere, from the food we eat to the essential balance within our bodies. Carbon is incredibly versatile, forming 4 strong bonds with other atoms, including itself. This allows it to create an astonishing array of complex molecules, the very basis of life. Hydrocarbons are the fundamental backbones of organic chemistry, built from chains and rings of carbon atoms bonded to hydrogen. They are the energy source powering our world. Polymers are giant molecules built from smaller repeating units called monomers. From natural proteins to synthetic plastics, they form materials with diverse and incredible properties. Functional groups are specific arrangements of atoms within molecules that give them unique chemical properties. They act like molecular attachments, defining how a compound behaves. Isomers are molecules with the same chemical formula but different structural arrangements of atoms. This subtle difference can lead to vastly different physical and chemical properties.